Good morning, students. Let's start further with chapter 5 after the continuity. In the previous lectures, I have given 2 lectures of continuity to you. In those lectures, I have told you how to check the continuity of a function at a point and in the interval and on a whole real line, how to check the continuity of a function. Now, today we will discuss about the first lecture on differentiability. By using continuity, how to check the differentiability on a function. For this, you have to check left-hand derivative and right-hand derivative. A function fx is differentiable at a point x is equal to x naught belongs to domain D if its left-hand derivative and right-hand derivative are equal, where left-hand derivative is limit h tending towards to 0 f of x naught minus h minus f of x naught upon minus h, and right-hand derivative is limit h tends to 0 f of x naught plus h minus f of x naught upon h. If you want to calculate whether the function is differentiable or not, then you can check the left-hand derivative and right-hand derivative. If both are equal, then function is differentiable. Further, if a function fx is differentiable at any point, that is x is equal to x naught, then the function fx is continuous also at that point x is equal to x naught. It means if function is differentiable, it implies that function is also continuous at the same point. If a function fx is continuous at x is equal to x naught, then the function may not be differentiable at x is equal to x naught. Converse of this above theorem, if function is continuous, it is maybe or may not be function is differentiable at the same point. What to do now? To prove that a function is differentiable at a point x is equal to x naught, then you have to prove left-hand derivative equal to right-hand derivative at that point. Suppose that is x is equal to x naught. Second formula, it is also written in some books. The f dash x, dash means derivative. F dash x is equal to limit h tends to 0 to the function fx plus h minus fx upon h. Sometimes it is also written that limit x tending towards the point, not tending towards h is not there, only x tending towards to, suppose x naught, then f of x minus f of x naught upon me h. You can use that formula also. I'm just giving you idea of both examples. First example is example number first. Show that function fx is equal to x if the range is x greater than 0, less than equal to half. It is 1 minus x if x is greater than half and less than 1, is continuous but not derivable at x is equal to half. Given function is continuous but not differentiable at x is equal to half, this you have to prove. Now for the continuity, as we know that left-hand derivative, right-hand derivative, both should, left-hand limit, right-hand limit, both should be equal to the value of the function at the point x is equal to half. Now we'll check left-hand limit and right-hand limit for the continuity of the function. Left-hand limit, x tending towards to half, minus sign shows that it is a left-hand limit. Limit x tends to half negative x, because less than half y is equal to x. I have put here x. Limit x tending towards to 0. Replace this x by what? Half minus h. If x tending towards to half, if you put x half here, then you will get h tending towards to 0. It means when you change the limit h tending towards to 0, you are getting half minus h. Put h is equal to 0, you are getting half. If you are checking right hand limit, then you have to take limit x tending towards to half of positive fx. The function is given less than half and greater than half. This is less than half, this is greater than half. That is 1 minus x. It means for the right hand limit, you have to take 1 minus x. Now for the right hand limit, you have to put x is equal to half plus h, x tending towards to half, then h tending towards to 0. It means limit changes. If you put x is equal to half plus h, now limit changes h tending towards to 0. Now simplify it, put h is equal to 0, you are getting half. Half at half, the value function is half. It means function is continuous because left limit, right limit and the value at the point, all three values are same. It means function is continuous. But you have to prove now it is not differentiable. Now apply the formula on it for the left hand derivative and right hand derivative. Now here I have used the formula not h tending towards 0, x tending towards to x naught. The formula will be fx minus fx naught upon x minus x naught. Here x naught is half. So put the values. F of x is given in the question x, and f of half is half, and x minus half, as it is, both are cancelled. You're getting 1. And when you apply limit, there is no x. That's why what? No effect of x is on 1. That's why it is only 1. Similarly, when you are calculating right hand derivative, limit x tending towards to half positive, right hand derivative. Fx minus fx naught upon x minus x naught. The value of fx when you're tending to from right, that is 1 minus x. From the question you can check, it is 1 minus x minus half and x minus 1 upon 2. Now simplify it, you are getting, when you cancel it, there is a minus sign difference in these two factors. It means when you take minus sign common, both will be same and cancelled out, it comes out equal to minus 1. Left and right derivative both are not equal. One is 1 and another is minus 1. So what if the left hand derivative and right hand derivative are not equal, then what function is not differentiable? So what this function is continuous but not differentiable at x is equal to half. Now second example is, show that the function fx is equal to mod of x minus 1 plus mod of x plus 1 for all real number is not differentiable at the point x is equal to minus 1 and x is equal to 1. You have to check for both. First of all, simplify this function for the values x is equal to minus 1, x is equal to 1. What interval you will get? Just check it. What interval you will get? Suppose this is whole number line. This is whole number line. I have to check it. I think it is not working. Okay, if you want to check x minus 1 equal to 0, it comes out x is equal to 1, and x plus 1 equal to 0, you are getting x is equal to minus 1. Now whole number line is divided into 3 parts. Suppose number line having minus 1, 0, 1 and extending from right hand side and left hand side. What you will get? Less than minus 1 interval, and second interval x greater than equal to minus 1 less than 1, and third interval will be x greater than equal to 1. Now you have to check what is the value of mod of x minus 1 when you are taking values from this interval x less than minus 1. This is negative, first one. Second is negative, you can check it, put the values, you will get the negative values. So what? Minus of x minus 1 and minus of x plus 1. Simplify it, you will get the function when x is less than minus 1. Put the values in between the interval, x greater than equal to minus 1 and less than 1. You are getting first is negative, second is positive. Simplify it, and if x greater than equal to 1, put 2, 3, 4, 5, and you are getting what? First and second, both the mods having positive sign. So 3 intervals will be there when you will check x is equal to minus 1 and x is equal to 1. I think it is clear now how we'll get the intervals. Now further, let's see the solution of this question. Now you will get, first is fx is equal to, after simplification, minus 2x. You are getting fx is equal to minus 2x. Second is fx is equal to 2. Third is fx is equal to 2x. Now to check the differentiability at x is equal to minus 1. Now you have to take left hand derivative formula and right hand derivative formula. Yes. Yes, you have to take left-hand limit formula, left-hand derivative formula, f dash minus 1, derivative of the function at x is equal to minus 1. And now I am applying left-hand derivative and right-hand derivative formula. Limit h tending towards to 0 negative. What was the formula? F of value x naught is minus 1. Minus 1 plus h minus f of minus 1 upon h. Simplify it. That is minus 2, minus 1 plus h, minus 2. Simplified, 2 minus 2 cancelled. You are getting minus of 2 after simplifying it. F dash minus 1, minus 1 plus h minus f of minus 1 h, limit h tends to 0 positive, because function having different values. When you are taking, you are going from left to the minus 1 sign or right to the minus sign, you are getting the different values. Here it is 2 minus 2 upon h, cancel out, 0 upon h, that is equal to 0. 0 and minus 2 both are not equal. It means function is not differentiable when you are taking x is equal to minus 1. Not differentiable. Now differentiability you have to check at x is equal to 1. Now again you will put here left hand derivative values and right hand derivative values. Put the values in the function given formula. In the first case, in left hand derivative you are getting 0, and right hand derivative you are getting value 2. 0 and 2 both are not equal. The function is not differentiable at x is equal to 1. It is not always possible to apply the definition method to solve the differentiability of the function. So we will do derivative direct using formula direct using sin x, cos x, and other functions which can be used directly. What are their derivatives? Theorem is here: if a function f is differentiable at a point c, then it also continues at that point. I have told you in previous slide also, if function is differentiable, then it is also continuous. But if it is continuous, it may or may not be differentiable. Every differential function is continuous. It is a theorem. Now, algebra of derivatives, which you have studied in the class 11th, that is, if two functions are added and subtracted, and you have to find out the derivative of that function, it means first function's derivative plus minus second function's derivative. If product's derivative you want to find out, first function derivative second as it is plus second function derivative first as it is. That is known as Leibniz theorem or product rule. If functions are written in quotient form u upon v, and you want to find out the derivative of this function, v square and v as it is derivative of u minus u as it is derivative of v, where v is not equal to 0. This algebra study you have done in class 11th in the chapter limits and derivatives. Same is here. Now here we will discuss about the chain rule. Let f be a real valued function which is a composite of two functions u and v. Suppose it is v of u. Suppose t is equal to ux. If both dt upon dx and dv upon dt exist, we have derivative of the function f is equal to dv upon dt into dt upon dx if you are doing the derivative with respect to x. Now it can be explained by taking the example. Suppose here I have taken fx is equal to, here I have taken fx is equal to sine of x square. Sine of x square. Now, as you know, y is equal to sine x. If it is given to you, then derivative of the function, you can say y dash will be equal to cos x. This you have studied in the class 11th in the chapter limits and derivative. Now here it is not x. It is x square. It means what? It is somewhere anything else than the x. Sine x square. So take it is t. Suppose it is t, and differentiating, you are differentiating with respect to x. If it is t, suppose y is equal to sine t, because you have taken what? X square is equal to t. Differentiating with respect to x, but here t is given. So how to do the derivative of the function? Then dy upon dx will be equal to sine x is cos x, but it is not x, it is t. So what? The derivative of this t will be again. You can do, if this apply this way, then you will get what? Cos of t into, it means what? Cos of t means x square, and derivative of t means, that is derivative of x square. We are getting 2x. It means answer will be 2x into cos of x square. This is a way reach up to the function with respect to x, if you are doing the derivative with respect to x. If it is with respect to t, suppose y is equal to cos of t is given to you, and you want dy upon dt, then it will be minus of sine t. Then there is no need to make the chain, because it is t and the function is required to differentiate with respect to t. So if it is t and it is t, then you can apply the formula directly. If the function is given in x, but function is given in t, and you are try to calculate the derivative in x, it means you have to make the chain to solve the derivative. Now here you can see here, yes, fx is equal to sine x square. I have taken x square is equal to t. Now differentiating f dash x is what? Sine x square dash, and it is t, it means sine t dash. What is sine t dash? That is cos t, and it is a chain because with respect to x we are going. So what? Dt upon dx. So it is cos of t into 2x, 2x into cos of t, value put again, that is x square. Further, in the next example, fx is equal to tangent of 2x plus 3. You know tangent x is secant square x, but it is not x, it is 2x plus 3. It means what? Make the chain, take 2x plus 3 as t. And what is the derivative of dt upon dx? You can calculate it. That is 2 only. Now here f dash x will be equal to secant square t into dt upon dx. Put the value of t here and dt upon dx. What you will get? 2 into secant square 2x plus 3. I think it is easy to understand now. Now you can learn the formula according to the chain rule. In previous class, you have learned the formula sin x, derivative of sin x is cos x, derivative of cos x is minus sin x. All these formulae you have learned in the class 11. But if it is not x, it is t. Here I have written, as in a chain rule, it is required. You are differentiating the function with respect to x, but function is written in t. Derivative of the function with respect to x, and function is written in the t form, t variable. So what? Sin t becomes cos t, and chain rule says that derivative of t again dt upon dx. Cos t minus of sin t and dt upon dx. D by dx of tangent t, that is secant square t into dt upon dx. Cosecant t minus cosecant t into cot t into dt upon dx. Secant t is secant t into tangent t into dt upon dx. Cot t is equal to minus cosecant square t into dt upon dx. If it is d by dx of ax plus b whole power n, that is taking n first and then ax plus b whole power n minus 1, and ax plus b derivative of this is a. It means what? A n into ax plus b whole power n minus 1. Suppose y is equal to sine of angle is written cos of x square. It means at the place of x, here cos x square is given to you. Now make the chain up to you are getting the x. Suppose you are differentiating with respect to x. It means sine whole is t. Sine t is cos t. The derivative of t again, it is a t. Now first as it is here. Now cos, again this is not x. Cos of t again. Cos t means minus of sin t. T is not x, that's why d by dx of x square. This chain goes up to, you are getting up to x. It means x square means 2x derivative is there. and x square derivative is 2x and minus sign this one, minus 2x cos of cos x square minus sin x square. This is a solution of the given function. Now we'll discuss exercise 5.2. In this exercise, first question is y is equal to sin x square plus 5. Differentiate the function with respect to x. Now this x square plus 5 is t. Now apply the chain rule formula. That becomes cos of x square plus 5 and derivative of x square plus 5 is 2x. We are getting 2x into cos x square plus 5. Second question, cos of t. T is here sin x. Cos of x is sin minus sin x, and this is what? Cos sin x. It means minus of sin t. Derivative of t again. We are getting the answer, this one. Now you can apply on third question same formula. Sin t cos t d by dx of t. T is ax plus b. Derivative of this is what? Only a. Fourth question. Y is equal to secant of tangent root x. Now here t is tangent root x. Now first of all, tangent t is equal to secant t into tangent t, derivative of this t again, tangent root x. Now you can see here, yes, y dash will be equal to secant t, tangent t, secant squared root t. Now it is not t again. It means derivative of root x. You have to find out. What you will get? 1 upon 2 root x. Other terms are as it is. Now you can write the values. This is the answer. Question number 5. U upon v algebra you have to apply here, and chain rule simultaneously will work here. Denominator square, cos square cx plus d, denominator as it is, numerator's derivative minus numerator as it is, denominator's derivative. Find out the derivative and you will get answer. Now question number 7, y is equal to 2 under the root cot x square. Now here you have to first of all simplify the power, then you have to go for the chain rule. Cot of x square under the root. If you solve the power taking half outside and 1 half minus 1, you are getting minus of half, and derivative of cot x square. Cot x square means cot of t. Cot of t derivative is minus cosecant square x square and d by dx of x square again, and this is the solution. Here you can simplify the question in the form of sine and cos, because answer is given in the form of sine and cos. Simplify it, you will get the answer. Write down the cosecant square x square as 1 upon sine square x square, and cot x square write down cos x square upon sine x square, and simplify the terms. You will get answer as in the form of it is given in the answer. Now you can do the exercise 5.2. I have done lot of questions for you. Do this exercise 5.2. Thank you. Have a nice day.